Good morning, everyone. We are discussing this chapter three-dimensional geometry, and we completed up to distance between two straight lines, that is the shortest distance between two straight lines. Now, today we will talk about the equation of a plane. But before that, just go through the definition of the plane. That is, the plane is a surface such that if any two points are taken on it, the line segment joining them lies completely on the surface. So it is explaining that if we take 2 points A and B on the plane or on the surface, sorry, not on the plane, this definition of plane. So taking 2 points on the surface, so the line segment, all the points on this line segment AB joining this A and B are completely lying on the surface. So if we take any point C here, C will satisfy the equation of the surface. Okay, so there is a theorem that says that the general equation of the plane is ax plus by plus cz plus d equals to 0. Or we can say the first degree equation in x, y, z represent the plane. So we are taking the first degree equation of in x, y, z is ax plus by plus cz plus d equals to 0. So that we need to prove that that will represent a equation of a plane. That means it will satisfy the definition of the plane. Okay. Now, but to prove that this will satisfy the equation of a plane, but we'll have to show we have to choose 2 points on the surface. That is, these 2 points will satisfy the equation, the first degree equation. And if we take any point on the line segment satisfying, if we can choose any point on the line segment and which satisfy the equation also, then we can show that the equation is satisfying the definition of the plane, and hence it will represent the equation of the plane. So we are taking 2 points P and Q. P is x1 comma y1 comma z1, and Q is x2 comma y2 comma z2. These 2 points we are taking. Since these 2 points are lying on the surface, that means that will satisfy the equation, these 2 points. So if these 2 points will satisfy the equation, we will get these two equations, equation 1 and equation 2. Now we're taking another point R on this line segment such a way that R divides the PQ into the ratio lambda is to 1. Now, if any point dividing any line segment joining 2 points into m is to n ratio, then you can easily find the coordinate of this point. So write down the coordinate of the R, which is given by x1 plus lambda x2 by lambda plus 1, y1 plus lambda y2 by lambda plus 1, and z1 plus lambda z2 by lambda plus 1. Now, if this R will satisfy this equation, then we can say this first degree equation is representing the equation of the plane. So let us check it will satisfy the equation or not. So put the x is x1 plus lambda x2 by lambda plus 1, y is y1 plus lambda y2 by lambda plus 1, and z is z1 plus lambda z2 by lambda plus 1 plus d. And if we simplify this, taking 1 by lambda plus 1 common, so we will get ax1 plus by1 plus cz1 plus d plus lambda into ax2 plus by2 plus cz2 equals plus d. Now look at the equation 1 and 2. The left hand side of the equation 1, and look at this here, and left hand side of the equation 2, and look at here. Now these two values are 0. Now if 0 plus lambda into 0 is always 0, so it will ultimately 0. That means the R will satisfying the equation, that is the first degree equation in x, y and z, that is x plus by plus cz plus d equals to 0. And from hence we can say that since R is any arbitrary point dividing the line segment PQ into lambda is to n ratio, lambda is to 1 ratio, that means for any point on the line segment, that is for all the points on the line segment, satisfy the equation, and hence it is satisfying the equation of the plane. Okay, so this will represent satisfying the definition of the plane, and hence it is the equation of the plane. Now let us check the some important points, that is equation of the yz plane, equation of the xy plane, like that. So equation of the yz plane is x equals to 0, and the equation of the plane parallel to the yz plane is x equals to constant, and equation of the zx plane is y equals to 0, and parallel to the zx plane means it is y equals to constant. Now equation of xy plane is z equals to 0, and equation of the parallel to the xy plane is z equals to constant. Now moving to the another point, that is equation of a plane passing through the origin, that is ax plus by plus cz equals to 0. Now when we will talk about the equation of plane passing through a point, that time the concept will more clear. So the equation of the plane parallel to the x-axis is by plus cz plus d equals to 0. That is the coefficient of x in the general equation of the plane is 0. Equation of the plane parallel to the y-axis is x plus cz plus d equals to 0. That is the coefficient of y into the general equation of a plane is 0. Equation of the plane parallel to the z-axis is ax plus by plus d equals to 0. Now, if two planes, equation of two planes are given, and it asks that the planes are parallel to each other or not. So, how to find the planes are parallel to each other or not? Just check the ratio of the coefficient of x, y, and z. Ratio of the coefficient of x, y, and z, that is a1 upon a2, b1 upon b2, and c1 upon c2. If the ratios are equal, we can say the planes are parallel to each other. Okay, now let us discuss the equation of the plane, different types of equation of the plane. Here also you can find the equation, the Cartesian equation and the vector equation. So let us discuss the Cartesian equation, and after that we will discuss the vector equation. So the equation of a plane passing through a point. What should be the equation? If we take the point as x1 comma y1 comma z1, then the equation of the plane is a into x minus x1 plus b into y minus y1 plus c into z minus z1, where a, b, c are constant. And one thing is very, very important to remember, that not all a, b, c are 0 in the equation of a plane. Okay, now from where we get this equation, let's check. So here is the general equation of the plane: x plus by plus cz plus d equals to 0. Now, if any point on the plane is given x1, y1, z1, that means it will satisfy the equation. So name it equation 1, and if the point satisfy the equation, that is ax1 plus by1 plus cz1 plus d is equals to 0. This is the equation 2. Now, if we subtract 1 2 from 1, so we will get a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. D cancel, and this is the equation of the plane passing through one single point. Now, if we change this into 3 points, that is the equation of a plane passing through 3 points. So let us take the points are x1, y1, z1, x2, y2, z2, and x3, y3, z3. These 3 points are given. You need to find the equation of the plane. So the equation of the plane is given by this determinant is equals to 0. Now, from where we can say that? Now, how we can say that this determinant will represent the plane? Now we have the equation of the plane passing through one point, that is a into x minus x1 plus b into y minus y1 plus c into z minus z1. We have that equation. Clear? Now, given that these 2 points x2, y2, z2 and x3, y3, z3, the points are also satisfying the equation of the plane. So that means we will get these two equations, that is x2 minus x1 b into y2 minus y1 and c into z2 minus z1 is 0. This is the second equation. And the third point is satisfying the equation of the plane, that is x3 minus x1 plus b into y3 minus y1 plus c into z3 minus z1 is equals to 0. This is the third equation. Now from these three equations, just eliminate a, b and c, and what we will get this determinant x minus x1, x2 minus x1, x3 minus x1, y minus y1, y2 minus y1, y3 minus y1, z minus z1, z2 minus z1 and z3 minus z1. Determinant value is equals to 0. Now this is the equation of the plane passing through 3 points. Now let us check the intercept form. Intercept form of the plane. Now you know that the intercept form of a straight line in two-dimensional, that is the line is touching the intersecting the x-axis at a length a, and if at a length b, then the equation of the line is x by a plus y by b equals to 1. So here also the plane is intercepting the x-axis at a length a, y-axis at a length b and z-axis at a length c. Then the equation of the plane is given by x by a plus y by b plus z by c equals to 1. Now how we can say this will be the equation intercept form? So let us take the x-axis, z-axis here and y-axis here. Clear? Taking this length is a. So this point is a comma 0 comma 0. So this is the point A. Taking this length is b. So the plane intercepting at a length b. So this coordinate is 0 comma b comma 0 and this is the point B. Now taking this length is c, intercepting length on z-axis is c. So the point C is 0 comma 0 comma c. Now we can easily establish the equation of a plane passing through 3 points. Now we have these 3 points, intersecting points with the axes and the plane. So 3 points we have A, B, C. Now let us find the equation. X minus x1, taking the x1, y1, z1 is a0, 0. So x minus a, then y minus 0, that is 0, z minus 0, that is z. Again 0 minus a, that is minus a, b minus 0, that is b, and 0 minus 0, that is 0. Again 0 minus a, 0 minus 0, and c minus 0. So this is equals to 0. That will represent the equation of the plane passing through 3 points A, B and C. Now let us find the determinant value. X minus A into BC minus Y into minus AC plus Z into AB is equals to 0. Now if we simplify this, so we will get BCX plus ACY plus ABZ is equals to ABC. Now divide the whole equation by ABC, we will get X by A plus Y by B plus Z by C is equals to 1. So here is the equation, that is the intercept form of a plane. From here also you can establish the equation Or from the general equation, you can also establish the intercept form. Ax plus by plus cz plus d is equals to 0. So we can write this thing as ax by minus d, divide the whole equation by minus d, by minus d plus cz by minus d is equals to 1. And this thing we can write as x upon representing minus d by a by another constant capital A, minus d by b by another constant capital B, and minus d by c by another constant capital C is equals to 1. So from the general equation of the plane, you can find the intercept form, and from the 3 point, the a plane passing through 3 points, from this equation also you can establish the intercept form. Now moving to the next point, that is the vector equation of the plane passing through a given point and normal to a vector. So taking that the position vector of the point is A and it is normal to the vector n. So taking the plane, and this is the position vector A, that is taking this point is A and whose position vector is vector A. So this is the vector A and this is the origin O. Now taking another vector n, which is normal to the plane, that is perpendicular to the plane. Now this equation of the plane is given by like this: vector r dot product with vector n is equal to vector A dot product with vector n. Now taking any arbitrary point P whose position vector is given by r. So this is the vector r. So from the figure you can easily say that AP is perpendicular to the vector n. Now what is AP? This is r vector minus a vector. So since they're perpendicular, then their dot product will be 0. So the r vector minus a vector dot product with vector n is 0. Now just break the product. R dot vector n is equals to a vector dot n vector. Now this is the equation of the plane passing through a point whose position vector is a and normal to another vector, vector n. Clear? Now let us, if we move this 3 point concept, that is the vector equation passing through the 3 points. So we need the position vector of these 3 points. So we are taking the position vector of the 3 points as vector A, vector B and vector C. So taking the plane and the points A here whose position vector is A, B another point whose position vector is B, and C another point whose position vector is C. Then the equation of the line is represented by this equation. Okay, now how? Let us check. Now this will the perpendicular to the plane and represented by this vector n is equals to vector AB cross vector AC. Okay, now we have a point A and we have a normal to the vector n. So according to the vector form of the plane, we can write that r vector minus a vector dot product with n vector is equals to 0. Or we can write n vector dot product with n vector, can we write this AB cross AC, vector AC. This is equals to vector A and this is AB cross AC. Now what is AB vector? B vector minus A vector. So just write it down. B vector dot product with B vector minus A vector cross C vector minus A vector. And this is A vector dot product with B minus A cross C minus A dot product with. Now look at here. R vector, just break this. So B vector cross C vector minus A vector cross C vector, and then minus B vector cross A vector plus A cross A vector. So for this side also same, A vector dot B cross C minus A cross C minus B cross A, and then plus A cross A. Okay. Now this thing we can write R dot B cross C plus R dot product with C cross A. Now I don't think I have to explain this thing, from where I can write minus A cross minus vector A cross vector C is plus C cross A, vector C cross vector A, plus R into A cross B, and this side A dot B cross C. Now A cross A is 0, so remove all the terms where A cross A you will find. So this thing we can write in the third bracket R B C plus R C vector A, and then vector R vector A vector B is equals to vector vector B vector C. So hence we established the equation of the plane passing through 3 points. Okay. Now let us talk about the normal form. Firstly, vector form, and then we will discuss the Cartesian form. So for the vector form, the normal form of the plane is the plane normal to a unit vector in cap and at a distance d from the origin, then that will be the equation of the plane. Now taking a plane, and this is the origin, and this distance is given d, taking this point is n, and where n cap is the unit vector along on. So n we can write d into n cap. Clear? D into n cap. Now just taking another point P whose position vector is r, taking point P whose position vector is r, and then joining that n and P. Okay. Now look at here. We can now say that this NP is perpendicular to this vector n cap. Now since it is perpendicular, so we can say their dot product will be 0. Now what is NP? Vector NP means R vector minus D into n cap Dot product with n cap is equals to 0. Now vector r dot product with n cap minus d into n cap dot n cap. Now since n cap is the unit vector, so we can write this value as 0. So vector r into n cap is equals to d. Here is the equation of the plane in a normal form, in a vector formation. Now if we move into the Cartesian form of the plane, so that will be the LMN should be the direction cosine of the normal to a given plane. Write down here plane which is at a distance p from the origin. So here we are taking the distance from the origin to the plane is p. Then the equation of the plane is given by Lx plus My plus Nz equals to p. Now what we have, the vector equation is r into n cap is equals to, since the distance is p, write down here p. Now r is any arbitrary vector, so x I cap plus y j cap plus z k cap. Now n vector whose direction cosines are given L M N. So we can write this thing dot product with L I cap plus M j cap plus N k cap is equals to P. Okay, so from here you can write Lx plus My plus Nz is equals to P. So from the vector form you can establish the Cartesian form, or you can choose the general form. From here also you can establish the form. So By plus Cz plus D equals to 0. So this is the general equation of the plane. Now divide the whole equation by root over a square plus b square plus c square. So a by root over a square plus b square plus c square into x plus b by root over a square plus b square plus c square into y plus c by root over a square plus b square plus c square into z is equals to minus d upon root over a square plus b square plus c square. Now what is this a by root over a square plus b square plus c square? This is L, the direction cosine, L, M and N. So Lx plus My plus Nz equals to P, taking this distance as P. Clear? So here is the normal form of the plane. So practice the equations of the plane. Just try to understand and establish the equation of the plane and transformation from to the general form to the normal form, general form to the intercept form. These transformations are very, very important, and to remember the formulas and to apply the formulas are very, very important. So go through the examples given in your book. Just try to find the try to solve the questions, try to solve the examples, and still then till then practice. And if any problem or any doubt is there, you're free to ask. Thank you.